All right, Algebra 2. Hey, we're going to start off with quiz 1.2. A couple of questions here about what we did last time. Okay, so here we go. Let's take a look at these. So what is the additive and multiplicative inverses of 4/9? Okay, so what we're going to do is we're going to start by writing 4/9. Okay, and what can I add to 4/9 in order to get 0? So in order to get 0, I would have to add -4/9. So that's the additive. Okay, then for the multiplicative inverse, what we're going to have to do is we're looking for something that gives you 1. Okay, so if I have 4/9, I have to multiply that by its reciprocal, 9/4. And that is equal to 36/36, which is equal to 1. All right, so that's number 1. Number 2 says to simplify this, we're just going to use our distributive property and combine like terms. Okay, so we're going to distribute out. All right, so we have 15x plus 30y. Okay, and then we're going to, since this is addition, we're going to add 4 times 2x is 8x. 4 times -9y is -36y. Okay, so now I can combine like terms. So the x's can be combined, then the y's can be combined. 15 plus 8 gives me 23, I believe. And then for the y's, I have positive 30 minus 36, so it's going to put me in the whole 6, so minus 6y. All right, so that is the quiz. Moving on. So this is now 1.3, solving equations. If you want to follow along in your textbook, that might be helpful to you. Let me just look to see what page this is on. This is on page 18 in your textbook. Okay, so page 18. Here we go. We're solving equations today. So we're going to translate some verbal expressions into algebraic expressions, and then we're going to use properties. So we're reviewing all of our properties, math properties, going back to some basics from Algebra 1 before we jump into some harder stuff. So here we go. An equation. So remember that an equation is a mathematical sentence stating that two things are equal. So inside equations, you will see equal signs. Inside expressions, you will not see an equal sign. All right, so you can always think of this equal sign as like a scale, like a balance, right? I'm terrible at drawing, but you know, they had these old school scales that look something like this, or if you put something on this side, this like a rock or something, this thing sinks, right? You think of the equal sign as the thing in the middle, right? So if there's a rock on this side, a certain mass, then we have to put something on this side that's the same, and then they're balanced, right? So an equation is balanced. You can think of an equation as a balanced scale. All right, so let's look at a couple of examples. Example 1, we're just going to be looking at for some key terms here. So we're going to kind of refresh some key terms with these verbal expressions. So it says the cube of a number. So the cube of a number, we don't know what the number is, so we'll call it x. We'll cube it. And then it says is increased by. All right, that's when we think increased by, it's usually addition. So we're going to add, and then it says 4 times the same number. So if I used x to represent the first number, I got to use it again because it's the same number. So we're going to say plus 4x. Okay, so you can use whatever variable you want. I chose x just because x is what we're super familiar with, but you could use whatever you want. For 1b, it says 3 times the difference of a number and 8. Okay, so 3 times the difference of a number and 8. So the difference of a number and 8, when I think of difference, I always think of subtraction. So I'm going to say, and since we're multiplying here, I could probably use parentheses. So 3 times the difference of a number, call it x, and 8. Boom. 3 times x minus 8. All right, so that's the first example. Second example, it says to write a verbal sentence to represent each equation. Okay, so for this one, let's think of a couple of key terms here. For subtracting, you can always use the word subtracting, or you can use less than, or you can use difference of. Equals is, we can always say the word is for equals. These are just kind of reviewing. So let's just try this one out. So this one says, so if I were just to say this, I could say g minus 5 is equal to -2. All right, so I could write it that way. Or I could say something like this. I could say the difference the difference of a number and 5 is -2. All right, so that's another way to think about that. Then for for 2b, okay, we could say 2 times a number, right? 2 times a number is, I'm going to say is equal to, we can say then the main thing going on between these two terms is subtraction, right? So it's equal to we can call it, it's a difference, right? It's equal to the difference of, now since this is the same in both, I'm going to say the same number of that same number squared and 4. That's one way you could do it. There's a couple other ways you could do it. I like this way because it's not easy to confuse it with anything else, right? So just make sure that you can't confuse whatever you write. Like if somebody were to read yours, make sure that if they read it, that they actually get this back out, right? So maybe you have a friend, a parent, a pet, just joking, read this over and see if it makes sense that you get this back out, right? Maybe don't show them what the original was. Okay, so a solution in these things, a solution is a replacement that results in a true mathematical sentence. Okay, so if I said 2 plus 3 is equal to x, okay, if I replace this x with 5, then the statement is true. So that's 5 would be a solution, right? So that's a solution. I know this is very basic, so I'm going to kind of just keep cruising through. Then we have these properties of equality. Okay, so it's, again, I don't really care that you know these terms other than us talking about them in class. It's best that you just know the rule. So if I have a number, okay, any number, or I can have a set of numbers, these examples are great for learning this. The reflexive property just says that if you have the same thing on both sides of the equal sign, that's reflexive, right? So if I said 5 equals 5, that's the reflexive property. Then the symmetric property says that if I have different things, okay, so say I had something like, there's this example that they give you here, but let's just make it even easier. What if I had like x equals 3? I can rewrite that as 3 equals x. That's symmetric, and I get the names of these mixed up from time to time. But yeah, symmetric. That would be symmetric. And then transitive. Okay, this is the cool one that we remember from from geometry class quite well. Same transitive property. If A is equal to B and B is equal to C, we can cut these B's out, and A is then equal to C, right? So if I said something like, well, we have it here. If I said something like this, 5p plus 3 equals 48, and 48 is equal to 7p minus 15, in the same system or the same group of problems, I can replace these 48s and just say, okay, well, 5p plus 3 must equal 7p minus 15. And then substitution, much like in geometry as well, we can always substitute something in. If A equals B, then A may be replaced by B and B may be replaced by A. Okay, so notice here we could substitute for 6 plus 1, we can substitute a 7 in to simplify that. All right, so those are some properties. Okay, so we'll come back to those as we go along here. So we're on example 3 now. So it says if negative 11a plus 2 is equal to negative 3a, then negative 3a equals negative 11a plus 2. Okay, so what they want us to do here is just name the property that is illustrated. So they're not actually having us do anything. But notice, this is one of those ones that we just talked about where we could get rid of this negative 3a, right? Oh, sorry. Spoke too fast. This is just a reversal, isn't it? So we have negative 11a plus 2 is equal to negative 3a. Negative 3a is equal to negative 11a plus 2. So these are just reversed. So if something is reversed, remember that we are talking about the symmetric property, where if a equals b, then b equals a. So we can call this, you can think of this as like a, b, and then notice over here it's b, a, right? This part is a, this part is b. Don't worry about this too much. I'm just trying to relate this to the rule. Okay, so this is not technically equal to b. Don't try to like complicate this any more than it is. I'm just representing negative 3a with b so that it can relate to this rule. All right, so that's the property, so you would actually write symmetric here. And that's all you have to do. You don't have to do any of this stuff that I did here. You just have to write symmetric. All right, so they'll have a couple of those in example 3 where you're just looking for the rule. And then example 4, you're supposed to solve your equation. Now, I think, if I remember right, maybe not, no. Okay, I was gonna say, sometimes they have you like state the properties of the rules when you're solving these things. So all we're doing is solving them. Okay, so using opposite operations, going back to our algebra 1. So if I want to get x by itself, that's really what I'm trying to do when I'm solving, right, is trying to figure out what x is. So I'm trying to get x by itself. So here I'm going to do the opposite operation. I'm going to add 14.29 to both sides. And then I'm going to have x is equal to 39.29. All right, here, same deal. I'm trying to solve for y. Right now it's being multiplied by 2/3, so I need to divide both sides by 2/3. Which is the same thing as multiplying by the reciprocal. So just a rule about that. Remember, if you divide by a fraction, you flip it and multiply. So it's the same thing. So I'm going to say or multiply, I'll use a little x, I guess, by 3/2, right? So I'm going to do that. So y is equal to, if I multiply both sides by 3/2, the 2/3 cancels on the left. And on the right, I have negative 18 over 1 times 3 over 2. I could do a little bit of cross canceling here. This is a 1, this is a 9, so this is equal to, and notice we had a negative there, so negative 9 times 3 is negative 27. All right, let's look at a couple more examples. Oh man, a lot more examples. Okay, a couple more examples, and then we'll get on with the homework. So here we go. 4, 5. So for this one, it just says to solve the equation. We're just going to use our rules if we can. So here, always start with our parentheses, right? So negative 10x, I'm going to distribute out. So plus 12x, just distributing, minus 6 is equal to 6. Okay, now I combine like terms, so I'm going to add 6 to both sides. Negative 10x plus 12x is 2x. Okay, so 2x is equal to 12. X is then equal to, when you divide both sides by 2, 6, right? And then for 5b here, so we have 4x minus 2, just distributing it out, and then I have negative 12x minus 4 is equal to 2. Same thing, let's combine our terms. So 4 minus 12 gives me negative 8x. Negative 2 minus 4 is negative 6. Okay, add 6 to both sides. Negative x is equal to 8. 8 is equal to negative 1. All right, so there we go. Example 6, we're now just taking this into another realm of like relating it back to geometry and stuff like that. So it says the surface area S of a cylinder is S equals 2 pi r squared plus 2 pi r h, where h is the radius of the base and h is the height of the cylinder. Solve the formula for h. So we're just trying to get h by itself. Okay, so what we need to do here, let me just start with this. Okay, let me just rewrite it. Okay, I'm trying to get this guy by itself. Okay, so first I can just move this whole thing over, right? So I have s minus 2, so this was being added in this thing, right? So s minus 2 pi r squared is equal to 2 pi r h, right? So now I got to get h by itself. It's being multiplied right now by 2 pi r, so I'm going to divide by 2 pi r so that these all cancel. And here I'll just divide this by 2 pi r. Don't try to cancel anything here because we need to have like terms everywhere, and we don't because of this s. So this is all we have to do, and we're done. So they might have you solve a couple of those for a variable. And you're just using opposite operations for those. Okay, we'll do some together in class. So example 7, if 5y plus 2 equals to 8/3, what is the value of 5y minus 6? So what we need to do for this is we need to figure out what y is equal to first, and then once we figure that out, plug that in for y here. Okay, so we have to solve this first. So I have 5y is equal to, let's move that 2 over by subtracting it, right? So I have 8/3 minus, now I'm going to change this 2, you guys, so that I have a common denominator. Okay, so I have to write it as a third. So 6 divided by 3 is 2, right? So 6/3 is the same as 2, right? So I'm going to do that. So here I get 5y is equal to 2/3. Okay, now I got to get y by itself by dividing by 5. So y is equal to, dividing by 5 is the same as multiplying by 1/5, right? So if I multiply this by 1/5, this goes away. Multiply this by 1/5, and I get 2/15. All right, so that's the first step. Then I got to plug that thing in. So now I'm going to plug that in there. So 5 times 2/15 minus 6 gives me 10/15, because 5 times 2 is 10. 10/15 minus 6. Now, this is a difficult problem to do if I don't have a common denominator, so I need a common denominator. Okay, so if I'm thinking about 15ths, if I want to get 6, I've got to multiply that by 6. 15 times 6 gives me, what does that come out to, 90? Right, so I can write it like that. So this is the same as 10/15 minus 90/15. Okay, and so now we just got to simplify this down. This is equal to 10 minus 90 is -80/15. And I'm pretty sure, well, let's see, does 5 goes into both of those. So that's equal to 5. So I'm dividing by 5 over 5. -16/5, I believe is what that simplifies down to. Sorry, made a mistake. It's early morning. 5 goes into 15 3 times. My bad. Okay, so I divided by 5 over 5. That's why you always show your work. See, I skip those steps and that's what happens. All right, guys, homework is what's up next. I think I have homework sheets for you. We'll see you in class.